Okay, so this is lesson 21. We're talking a whole lot about different functions and just evaluating them, determining the domain and the range. Okay, the evaluation of a function is very simple. The notation just looks different. So you're used to seeing things like f of x equals this, and I've told you that that means y. But if I say f of 2, that means you put a 2 for the x on the right-hand side. So f of 2 is just simply this. And then you just work it out. And of course you get 8 here. Okay? So if you want to do this one, in f of 270 degrees, then I'm going to put 270 where the x is. So that's 4. And then I have to figure out what the cosine at 270 is. So it's coming around here at 270 degrees. So it's going to be the coordinate, which is 0, -1. It's going to be the coordinate on the unit circle right there. And we know that cosine is the x. So we have 4 times 0, and we get 0. Okay. Now doing the same thing here, but this time we're going to put x plus h wherever you see an x. So there's an x right here. I'm going to put x plus h in it. And there's an x right here being multiplied to the 3, so I'm going to put an x plus h there. So this is a square, so you can use the square rule. So you square the first one, multiply them together and double it, square the last one. You can do distributive property with the 3. And then we need to look and see if we have any like terms. But as you can tell, we do not. Therefore, this is just it. Okay, so flip over to the back, or I guess in your case it's probably page 2. And we're going to do this one, and we're going to do this one. So just like what we just did, I'm going to put this into this function where the x is. So it's -2, and the x is squared. I'm going to put x plus h where the x was. Plus 3 times x, I'm going to put x plus h where the x was. Minus 4. That's this part right here. Okay? And it says minus, and then I'm going to put an x where the x is. Now, you know, I could have said an a, but I just kept it the same. So it's just going to look the same. Okay, so this is -2. We need to do our square rule. So x squared plus 2hx plus h squared. You can go ahead and do distributive property here. Here, this is minus all of this, so I'm going to be changing the signs of every one of these. I need to do distributive property here. Bring everything down. Now we'll look for like terms. Here's an x squared and here's an x squared, and they're actually going to cancel each other out because they're opposites. Here's a 3x, and here's a -3x. They're going to cancel each other out. Here's a -4 and a 4. They're going to cancel each other out. So I'm left with these. -4hx minus 2h squared plus 3h. And that's what's left. Let's try it again. I know this is confusing because you're thinking there's already an x there. What do you mean you're putting x plus h? Remember, the x is a variable. It's just like a placeholder. So 1 over, we're going to put x plus h where the x is. Okay, minus. And then we're going to put an x where the x is. Now, of course, we need to get a common denominator. So I have a 2, I have an x, and I have an x plus h. So to get a common denominator, I'm going to need to use 2 times x plus h. All of it. That means I'm going to multiply this one by x over x. I'm going to multiply this one by x plus h over x plus h. So I'm going to have x, and I'm going to have minus both of these. So minus x minus h. So those are going to cancel out, and I'll get -h over 2x times x plus h. And that will be your final answer. Let's try it again. This time it has an h in the bottom. So the x plus h I'm going to put right there. So -2 x plus h squared minus 2. So you notice I'm using all of it each time. Minus, and then an x there, over h. So this is going to be negative 2 times x squared plus 2hx plus h squared minus 2. This is going to distribute. Oh, wait a minute, I got to have a parenthesis right there. I didn't do that. I'm sorry. This is going to distribute, and that's going to be a positive 2x squared and a positive 2. This is over h. So right here I need to do distributive property. So negative 2x squared minus 4hx minus 2h squared, and it's minus 2 plus 2x squared plus 2. And this is over h. This one's going to cancel that one. This one's going to cancel that one. So in the top, I have an h in both terms. So I can factor it out. It's over h. So those can cancel. So my final answer then is negative 4x minus 2h. Okay? Go to the next page. There's lots of practice here because I know it's confusing. I am, though, going to jump down to here for the domain. So it says find the domain of this. Okay. So the way you find the domain is you first think, what are the problem areas? What kind of problems could you have with this expression? Well, we can't have the square root of a negative, can we? We cannot have that. So what does that mean? That means that 2x minus 4 has to be greater than 0. If it's not negative, it's greater than 0. But can you have the square root of 0? So is it greater than 0, or is it greater than or equal to 0? Well, if you look, you can use your calculator if you're not sure, but the square root of 0 is 0. That's legit. You just can't do the square root of a negative. So it's greater than or equal to. Then we're just going to solve this. Okay, so then that's the only problem that I would have there. There's nothing that makes it undefined otherwise. So we're going to say the domain, you can use a D for that. And then you say x is an element. Use that element sign from geometry. The set of real numbers, it's like a double bar with an R, such that x has to be greater than or equal to 2. Okay, so this is your answer. So what would be the problem areas in this expression? Okay, well, the problems would be that x minus 10 cannot be negative, so it has to be greater than or equal to 0 for that. And down here, this cannot end up being a 0. So x squared minus 5x plus 4 cannot equal 0. So let's find out what that makes x equal to in each case. So here, x has to be greater than or equal to positive 10 then. Here, I'm going to factor it. So we're going to get x, we got a negative 5 and a positive 4. So negative 4 and negative 1. So that means x cannot be 1 or 4. It can't be either one of those. Okay, so the domain, x is an element of the set of real numbers. And we use these braces, remember, for set notation. Now, I'm going to say x has to be greater than or equal to 10. Now, I could put here an x cannot be 1 or 4, but if it's greater than or equal to 10, it's not going to be that anyway, is it? So that's sufficient right there. And by the way, remember now, the reason this can't be equal to 0 is because you have an undefined expression because the bottom can't be 0. Okay, let's flip over and look at a graph and think about domain and range. So domain, reminding you, it's what the x's are, and this is what the y's are. Okay, so to look for the domain on a graph, it's really very simple, much easier than algebraically. So you just look at the graph and think, what is the smallest x that you see and what's the biggest x, okay? So you can see that this x right here, coming this way on the x-axis, that's as far left as it goes, and that's a negative 3. Okay, and it's equal to that. So x has to be greater than or equal to -3, and the biggest one, just count over and you'll see that it's at 6. And it is not equal to 6 because it has an open circle, so less than 6. So back it up a little bit here. I'm going to say x is an element of the set of real numbers such that that's true. And that is your domain. And in the range, you start it similarly, but you say y is an element of the set of real numbers such that, see, then you look, what is the smallest y? Well, the smallest y is way down here, and if you count, you'll see that's -9. And it's not an open circle, so it's, use the or equal to, and the highest one is this one here, and that is 5 on the y-axis, but it's not equal to it, so less than 5. So this is your answer, domain and range. Number 11 says, determine whether the graph represents the graph of a function, and if so, determine whether the graph is a one-to-one function. So the function test is what we call the vertical line test. And what that means is if you can draw a vertical line anywhere in the graph, and you hit the graph twice, in other words, you hit it more than once, because you might hit it multiple times, not just twice. If you can hit it more than once, then it is not a function. So obviously, I could draw vertical lines in many places here and hit this graph twice. Therefore, this is not a function. Okay, so it's not a function. If it's not a function, it is certainly not a one-to-one function. It has to be a function to even be a special kind of function called a one-to-one function. The one-to-one function test is called the horizontal line test. Okay, so let's look at something here. So what if I have, say a parabola, just your basic y equals x squared parabola. Okay, this is a function. It is a function because I can draw vertical lines and I never hit it but once. It is not a one-to-one function because if I drew one just right there or anywhere in this area, I would hit it more than once. So it is a function, but it's not a one-to-one function. Okay? What about a line? So I can draw vertical lines through it, only hit it once, so it is a function. I can draw horizontal lines through it and only hit it once, so it's not, I'm sorry, it is a one-to-one function. So the two tests are the vertical line test and the horizontal line test. The vertical line test is determined if it is a function at all. The horizontal line test determines if it's a one-to-one function. Okay? So I hope that was helpful.